Hello everyone, welcome to our pre-calculus class. This is lesson 20, further applications of linear functions. So in this lesson we will try to extend our ideas for forming linear functions. From the basic real life application, we will try to make a couple of couple of equations that will represent the real life situation. So let's try to look at the agenda. One math is related to truck rentals, then cost of driving a car. This is two quick maths, quick model we will try to develop. And then we have a simple situation like a table, situation a company car, new machine. These are all depreciation related math. Depreciation means decrease over time. If the value of something decreases over time, this is called depreciation. Then a couple of reviews and homework kind of thing. Okay, so we have here, so this is the linear model or linear function will look like this. I mean, linear model will look like this, y equal to mx plus b, and this is the function form. Okay, you can represent in either this way or that way. Both will mean the same thing. Okay, so output equals to rate into input plus some constant number. This is the formula. This is the rule. Output equals to, output is y equals to rate by which something is increasing, that is the rate. Then input, and we have some constant. You see, input is x here. Input is x here. That is the value. Let's look at two examples here. Truck rentals. A truck rental company rents a moving truck for 1 day by charging $29 plus 0.20 cents per mile. Write a linear equation that relates the cost C in dollar of renting the truck for the truck to the number of x of miles driven. So up to here we have our first part of the math. Then two new question follows here. Now how can you write, question is write a linear equation that relates the cost in dollar of renting the truck to the number of x miles driven. So how can you make this equation? How can we make this equation? Now you see, this looks like something like real life situation. Let me give you some real life situation. Suppose you have, let's say, $20 now with you, and then let's say your mother said that she will give you $10 every month. $10 every month. Okay, every month. $10 every month. Now, how can you find out some mathematical equation by which you can actually do some calculation that will tell you after, let's say, 6 months what will be your money, total amount of money. Of course, you can do it manually, like 6 into 10 means 60. 60 plus 20 goes to $80. So after 6 months, you will get the $80. But mathematically, if you want to find it out, then what can we do? How can we find out some equation that will represent the total amount of money after any number of months? So your total money, let's say total money is T. Okay, total money is T. Let's say total is T equals to, so you already have this $20, so that's why 20, already you have this thing, then plus $10 every month. That means 10 into M, $10 every month. Now you can see after 6 months you can just put for M, you can instead of M you can put 6. Then 10 into 6 means 60. 60 plus 20 means 80. Now if someone asks, okay, after 12 months what will happen, then for this M you can write here 12, then 12 into 10, 120. 120 plus 20 means 140. So you get the solution. That means when you have some mathematical model, this is called the model. When you have some mathematical model, then actually you can put the value and do the calculation for any number of months. Also, this model actually helps you another way. Suppose your target is $200. So how many months you need to get $200, to have $200 in total? How many months you need? Suppose this is a question. You want $200. So based on this situation, total money you need $200. Now you can put here 200 here, then try to do the calculation for M equals to what? That will give you the required number of months. So this is a situation that is related to all the real life application of linear functions. Linear model, all of them will work like this. In this case your money is increasing, that's why plus. If the money is decreasing, then there will be minus here. That's the only difference, nothing else. So see here what happens. This $29 is the money. So $29 you have to pay more regardless of what happens. Then plus this $0.20 per mile. So that means 0.20 per mile. So the mile is x. Number of mile is x. So you can write here x. And total cost is C. So you can write here C equals to this. So this is the model. This is the model. And for 110 miles, you just have to put x equals to 110. 230 miles means you have to put here 230. Cost of driving a car. The annual fixed cost of weighing a small sedan are this, assuming that the car is completely paid for. The cost for driving the car is approximately this per mile, this dollar per mile. Cost C, x number of miles. Exactly similar kind of question. So how can you develop this equation? So C equals to 1289, then plus 0.15 of x. Okay, so this is the model, and the answer is also written here, you can see. So this is how we can develop some equation from the given situation. This is a practical situation from our life, and then this is how you can make an equation that will represent this practical situation. This is called model, and you can actually do this kind of experiment with your life also. If you have this kind of examples, okay, you can make some mathematical equation. That mathematical equation can help you to think about the future. That's the beauty of maths, elegance of maths, and the power of maths. The power of maths. There is a saying. This is funny. There is a saying that if you trust someone, some people, they may cheat with you, but mathematics is something they will never do the cheating. They will never cheat with you. They may cheat and they may leave. They may come. They may go out and never do this or that. But mathematics will always behave the same way. And also you can trust it. That's the best part. So yeah, this is the straight line depreciation. Now we will start as depreciation related maths. Depreciation means decrease in value. Suppose you buy a mobile phone. Then when you buy a mobile phone, let's say this mobile phone is 20,000 BGT, suppose. After buying this mobile phone, after 1 year, can I sell it 20,000? Can I sell it 20,000? Is it possible? It's not possible. People will not buy it even for 10,000. Okay? People will not buy it even for 10,000. So that means the value of this mobile phone is decreasing over the time. The value of the mobile phone is decreasing over the time. How much it is decreasing over the time? That you can decide. You can think like maybe we can think like this. Let's say this. I can think like, okay, this mobile phone will be good for using, let's say, for 3 years or for 4 years. So suppose that I will use this mobile phone for 4 years. That means, say this. Suppose this 20,000 BDT. So this is the cost of this mobile phone, and I have decided that this mobile phone I can use maximum for 4 years. Okay, suppose 4 years. That means in every year, the price of this mobile phone is decreasing by 5,000. Okay, so 5,000 in first year, then another 5,000 in second year, another 5,000 in third year, another 5,000 in fourth year. Then at the end of the fourth years, the price of this mobile phone is zero. So yeah, and then if I can sell it by 2,000 or 3,000, then this is my profit. You know, I'm kidding. But this is how, although I am kidding, but this is how all the big company they do their calculations for their assets. When they buy, think about it. When they buy some computer for their employee, you see, let's say they buy for $1 million accessories for the company, and after 5-6 years, this $1 million accessories will not be worth of $1 million. That means they are using the value of the product. Okay, and they have to calculate it. They have to take all these things into account in their calculations, or else there will be some miscalculations in their profit. So they have to think about this. What are the assets? What are the, let's say, electric bill? Let's say electric bill is a little bit different. Let's say their furniture cost, their computer cost, their all the electric gadgets, electric things, electronics, and the furnitures, everything, all this kind of thing that they buy and people use, and then that they loses their value over the time. So for all of them, we have one word. This is called depreciation. The value decreases over the time. This is called depreciation. And straight line depreciation is this one. Every year it will decrease by the same amount. This is called straight line depreciation. This is called straight line depreciation. Let me show you one example. A company office table was purchased for $500 and will lose all its value over 10 years. So that means they bought a table, and after after 10 years, the table will lose its value. That means, so $500 in 10 years. That means in every year, $50 it will lose. Let me drink some water. So write a linear function for the table t that is x years old. So how can you write that equation here? Now see, in each year it will lose $50. It started from $500. So this thing, see, it started from $500. This is the model. Actually, the whole model is this one. And every year it is losing $50. That's why minus. Lose, decrease. That's why minus. So minus 50x plus 500. minus 50x, this minus 50x, depreciation, that's why minus, x because month, every year is x here in this question, and why this 500, because we started with this 500, okay. From this 500 the value will decrease. So this is the model for the depreciation. Only difference between this math and the previous math is here we have a negative sign, and negative sign is because decrease in value, that's why. Graph, how can we graph it? Like, now think about some value of x equals to 10, x equals to 20. 20 is too much. X equals to 10 or x equals to 0. You put the value, then you can graph it. So the graph will be like this. For x equals to 10, value is 0. For x equals to 0, the value is 500. This is the graph. What is the value of the table after 4 years? That means if you put x equals to 4, what is the answer? If you put x equals to 4, because 4 years, years means x. So if you put 4 here, do the calculation, that means after 4 years, the value will be $300. Interpret the slope. So our slope here is minus 50. That means in each year, the value will decrease by $50. Decrease means minus. This is the slope. Minus 50 is the slope here. Okay. The value of the car decreases by $50 per year. This is the interpretation of the slope. What will be that? This will be table actually. What will be the table's value? When will be the table's value be $200? That means we have to put 200 here and find x equals to what? So t of x equals to 200. Then find out x equals to what? X equals to 6 is the answer here. So depreciation related all math will actually follow this exact same order. Just only this value will be different for different maths, and this value will be different for different maths. And but the methodology will follow exactly the same. Let me show you another example with some bigger value. Suppose $28,000 now for a car over 7 years, it will depreciate. So 28,000 divided by 7, it becomes $4,000 per year. So you see, this is $4,000, but there is no big difference between the previous maths and this maths. Now write a linear equation. This is the linear equation. V of x equals to minus 400x plus 28,000, because this is the starting now, and this is the decrease. Rate of the decrease is this. And how to graph it? Again, put the value of x equals to 0 and x equals to 7. This 7. In this math, what happens if we put x equals to 10? Think about it. Can we put x equals to 10 in this math? Think about it. And if you understand, that's good. If you don't understand, you can ask me this question during the class, or we can discuss this question during the class. This is the graph. After 3 years, what will be the value? That means x equals to 3 we have to put, just like the previous math. 3 put here and just do the calculation. Interpret the slope. That means value will decrease $4,000 per year. When the car's value will be $8,000, that means $8,000 will be here now. Put $8,000 here, then find out x equals to what. Like this. Calculation is this. Another math, exact same topic. Another math is straight line depreciation. See, this is from the book. $128,000. Company just purchased a machine for manufacturing facility, which is $128,000, and 10 years is the time for depreciation. So we have to first divide it by 10 to get yearly depreciation. So our yearly depreciation is $12,000, because if you divide it by 10, 0 cancel out, so you have $12,000. So our equation, this model will be minus 1200,000 x plus 120,000. Just the difference is the value is a little bit bigger here. Okay. What is the implied domain of the function found in the part A? What is the domain here? So domain is basically, you see, the domain is the input. How much input is possible? What is the valid input? What is the possible input for this math? So you see, Their target is to use it for 10 years. 10 years. So 10 is the maximum value for this math. And of course, it will start from 0. 0 means now. I mean, the point when the company started all this thing, that is 0. So from 0 to 10, that is the domain. 0 can be included, 10 also can be included. So that is the domain. Graph the function, same method, you put some value here, then plot it. That's the graph. After 4 years, what? That means put x equals to 4. 72,000 will be when the value we have to put. This is the after 4 years. This is what happens. D equals to this. When will the machine have a book value of this $1,000? That means we have to put 72,000 here, $72,000 here. Then find out x equals to what? Answer will come 4. So that's the math. And then supply and demand math. Just to give you for a quick look, we actually discussed this kind of problem. We discussed this kind of maths in our previous class. Two equations are given. To find out the equilibrium, we have to say that this equal to this. Equilibrium quantity. So this and this we have to equate. Then p equals to what? Put the p in the given function. Then we will get the equilibrium quantity. Find the supply where it is greater. Supply is greater than demand. That means SP is greater than DP. This is just a review math. Exact same question and exact same graph here. Okay, just a review question. Another review question from supply demand math. Similar kind of problem. What is the equilibrium price? Equilibrium. For equilibrium, we have to write this equal to that, because equilibrium means balance. When SP and DP is equal, this is called equilibrium. That's why this equal to this. We have to write it. So then graph the both function. What is the equilibrium price? So P will be equilibrium price. For graphing, you can do it conventionally also, like think about some value of P and then try to graph it. But based on the math, you need to choose the scaling for your graph. Okay. In our online setup, actually, we do not give this maths during the exam, but still, it is better if you learn how to draw it. Okay. So for different value, we have this is the intersection. Actually, this is the equilibrium. This equation and this equation will intersect at a point. Okay. That intersection is called the equilibrium. From the graph also, you can actually find out the answer. So 2 new questions are given. You can do experiment if you want with them. These are the homeworks. Try to solve some homeworks from here. Review means some works from the previous slides. Actually, we'll decrease them. We'll remove a couple of things. Anyway, so that's all for the moment, for this moment, and see you all in class. Thank you all. Thank you very much. Bye-bye.